The basic question is about American farm populations and their decline from 1935 to 1980. For part A, we had to make a scatter plot of the data and find the least squares regression line of the farm population per year. The least squares regression line was y hat equals 1166.9273 minus 0.5868x. And here is the scatter plot of the data, which was made by putting the data into list 1 and list 2 in the calculator. And for B, the population of people living on American farms declined an average of 0.5868 million people per year. And for C, you cannot reasonably predict the population in 1990 because you cannot have a negative population. As you can see right there, it's a negative number, and because it is extrapolating the data. The advanced question was about the relationship between the number of powerboat registrations and the number of manatees killed in Florida. For A, the variables are positively linear, and for B, the scatter plot shows a moderately strong and linear relationship. As the number of powerboat registrations increase, the number of manatee deaths tend to increase too. And for C, the relationship is relatively strong. The number of manatees killed can be accurately predicted at about 45 to 50 manatee deaths per year if boat registrations remain constant at 719,000. The AP question was about the relationship between the wind velocity in miles per hour and the electricity production in amps created by windmills. For part A, we had to use a computer output to determine the equation of the least squares regression line and identify all variables used in the equation. So, the equation for A is y hat equals 0.137 plus 0.240x, and y hat is the estimate of electricity production in amps, and x is the wind velocity. For B, we had to figure out how much more electricity that the windmill could produce on a day when the wind velocity is 25 than on a day when the wind velocity is 15. So in order to get the answer, we had to use that and insert 15 and 25 for x. And so for 15 miles per hour, you get 3.887 amps, and for 25 miles per hour, you get 6.387 amps. And so there are about 2.5 more amps of electricity generated at a wind velocity of 25 miles per hour than there are at 15 miles per hour. So then using the computer output diagram, you could tell that there was about an 87.3% variation in electricity production explained by the linear relationship with wind velocity.